The space race, a fierce 20th century competition for spaceflight supremacy. Two Cold War rivals, the United States and the Soviet Union, vied for technological dominance, shaping history and inspiring generations. This is their story. Born from the ashes of World War II, the Cold War ignited a new kind of rivalry. Both nations sought strategic advantage, a tense standoff defined by ideological differences and the threat of nuclear conflict. The foundation of the space race lay in ballistic missile development. Originally designed for nuclear warfare, these powerful rockets soon became the vehicles for humanity's first ventures beyond Earth. Technological prowess in space was seen as vital for national security. It promised advanced reconnaissance and undeniable military capability, turning the cosmos into another front in the Cold War. On October 4, 1957, the Soviet Union launched Sputnik 1. The world was stunned. This small, beeping satellite marked the dawn of the space age and a profound blow to American confidence. Sputnik's success spurred the United States into action. A missile gap fear gripped the nation, accelerating efforts in science, education, and rocketry to catch up to their Soviet rivals. Just a month later, Sputnik 2 carried Laika, the dog, into orbit in November 1957. A tragic but pioneering flight, it demonstrated the Soviet Union's continued lead in biological space research. The U.S. responded with Explorer 1 in January 1958. Launched by a team including Wernher von Braun, it was America's first satellite, detecting the Van Allen radiation belts and restoring some national pride. Early rocket development relied heavily on repurposed military technology. The Atlas and Jupiter rockets, designed for ICBMs, were adapted to launch the first American satellites and human-crewed spacecraft. Both nations also saw space as a grand frontier for human endeavor. Visionaries like Wernher von Braun had long dreamed of space stations, inspiring a future beyond Earth's atmosphere. In October 1959, the Soviet Luna 3 probe captured the first images of the moon's far side. This feat provided humanity with an unprecedented view of our closest celestial neighbor. A pivotal moment arrived on April 12, 1961. Yuri Gagarin, a Soviet cosmonaut, became the first human in space, orbiting Earth aboard Vostok 1 and becoming a global hero. The Vostok program was a triumph of Soviet engineering. Its capsule, though rudimentary, proved that humans could survive and operate in the harsh environment of space, opening doors to further exploration. Less than a month later, on May 5, 1961, Alan Shepard became the first American in space. His suborbital flight aboard Freedom 7 proved the U.S. could also launch astronauts. America's Project Mercury aimed to put a man in orbit. These one-man capsules, launched atop Atlas rockets, were a crucial step in gaining orbital experience and closing the gap with the Soviets. In February 1962, John Glenn orbited Earth 3 times, becoming the first American to do so. His flight was a significant milestone, proving U.S. human spaceflight capabilities. Beyond Earth, robotic probes explored new worlds. In August 1962, Mariner 2 became the first spacecraft to successfully fly by Venus, sending back critical data about the planet. The Gemini program, initiated in 1965, was a vital stepping stone. Its 2-man crews practiced rendezvous and docking maneuvers, essential skills for future lunar missions. Gemini missions also saw the first American spacewalks, where astronauts tested extravehicular activity. These daring ventures pushed the boundaries of human endurance and engineering. In February 1966, the Soviet Luna 9 achieved the first successful soft landing on the moon. It transmitted the first panoramic images from the lunar surface, a major robotic achievement. Tragedy struck on January 27, 1967. The Apollo 1 fire claimed the lives of 3 American astronauts during a launch rehearsal, a devastating setback for the lunar program. Just months later, in April 1967, Soviet cosmonaut Vladimir Komarov died during the re-entry of Soyuz 1. These twin tragedies underscore the immense risks of space exploration. Despite the setbacks, both nations pushed forward with resolve. The drive to reach the moon, fueled by national pride and strategic imperative, proved stronger than the perils. In December 1968, Apollo 8 orbited the moon, carrying humans beyond Earth's gravity for the first time. The iconic Earthrise photo redefined humanity's perspective of its home planet. The race to the moon intensified, with both the U.S. Apollo program and the Soviet N1L3 program vying for the ultimate prize, the first human lunar landing. The world held its breath. On July 16, 1969, the mighty Saturn V rocket launched Apollo 11. A crew of 3 astronauts embarked on a journey that would fulfill President Kennedy's ambitious challenge. 4 days later, on July 20, 1969, the lunar module Eagle touched down. Neil Armstrong famously announced, "The Eagle has landed," marking humanity's arrival on another celestial body. Hours later, Neil Armstrong stepped onto the lunar surface, followed by Buzz Aldrin. Their footprints marked a monumental achievement, a symbol of human ingenuity and courage. Armstrong and Aldrin spent hours exploring the Sea of Tranquility, deploying scientific instruments and collecting lunar samples. Their meticulous work provided invaluable data about the moon's composition. The world watched in awe as images from the moon captivated millions. The moon landing transcended political divides, becoming a shared human experience and a moment of global unity. Following Apollo 11, 6 more Apollo missions landed on the moon, bringing back more samples and conducting extensive scientific research, dramatically expanding our understanding of the lunar environment. Beyond the moon, robotic probes pushed deeper into the solar system. The U.S. Viking landers explored Mars in 1976, while Soviet Venera probes successfully landed on Venus, revealing its harsh surface. The era also saw the advent of space stations. Skylab, America's first, and the Soviet Salyut program provided platforms for long-duration research and paved the way for permanent human presence in orbit. As the Cold War tensions eased, a shift towards cooperation began. The intense zero-sum competition of the space race gradually gave way to shared scientific endeavors and international partnerships. In July 1975, the Apollo-Soyuz